Exception handling. What we're going to do now is turn our attention to dealing with issues that may occur in your programs. Namely, what happens when an error occurs. Now, I'm not talking about errors that occur as a result of you maybe having a syntax error or even having necessarily a logical error, although a logical error could occur. Mostly what I'm talking about is what happens when the system or the environment in which you're programming is behaving unexpectedly, and what happens when a user kind of does something that you didn't plan for. So what I'm going to do is, before we start coding, I'm going to give you some nice overview and key terms about what are called exceptions and what I'm talking about here. Then what we're going to do is move into the syntax, and then I'm going to show you the API, or what you can do with Java in terms of creating and handling your own errors. Before we get started, let's understand what an exception is and understand what it is by utilizing some key terms. Now, what we have to understand is eventually you and I will be writing programs together, and then eventually you on your own will be writing programs that do things like maybe open up a network socket to a server across the network. Maybe you'll want to open up a file and look into a file or save a file. Well, what happens when the server that you're trying to connect to across the network is down? It's not available for a number of reasons. What happens when a file that you're looking for simply isn't there? We've got two choices. One, the program will just crash and die, and the user will have a horrible experience. Or two, what you can do is implement exception handling. And exception handling in an exception is really dealing with exceptional conditions. Things that you really can't plan for, like a server being down. You always assume that it will be there, but the exception is that it will not be. So what you want to do is you want to give your program an alternate path of flow or execution should such an exception happen. You never want the program simply to just crash and the user to be faced with, a horrible error message. If the server's not there that you're looking for, you want maybe to put up a window that says, look, the server's not there. Why don't you click around to try and locate another server? Or if the file that you're looking for is not there, you don't want the application simply to say file not found, crash and die. No, what you want to do is put up a mechanism, put up a window that allows the user to click through maybe and find the file maybe somewhere else. Maybe they've put it somewhere. Now, tons of things that can lead to exceptions are like hardware failures. You can also have resource exhaustions. Resource exhaustion simply means you've ran out of maybe memory. That's a pretty serious error, and it's pretty hard to deal with something like that. And then, of course, you can simply have your bugs, good old-fashioned bugs in your code. Now, when Java encounters an exceptional condition, the term that is said to be used is that you are throwing the exception. So you'll hear that a lot. An exception is thrown. Okay, boom, it just goes right up in the air. This exception, this exceptional condition, think of it as an object or like a baseball bat, goes up into the air. Now, the code is going to handle the exception. We're going to write code to handle that exception. And that is called an exception handler. And that's basically your code that you write that will happen, that will deal with the exception. Okay, it's going to deal with the exception. And the exception handler, what goes up must come down, right? So when that ball, that exception just gets thrown up in the air, it comes down. And hopefully, if you're doing it correctly, you will catch that by your exception handler. Okay, so that's some terms, that's the understanding of what's going on there. Now, what happens when an exception occurs is your program is moving along. What will happen is when that exception is thrown, special code will then kick in. Your program no longer functions in its traditional path. Now what happens is the special code kicks in and a new direction is taken. You could, if you want, return to the original. Maybe you fix a problem and then return back to the original area. However, it's important to understand that when an exception is thrown, program execution, the flow of it radically changes its direction. Okay, so now what I want to do is start focusing in on the syntax. The syntax for catching exceptions and handling with errors is called a try-catch block. And it basically looks like this. Now, I've set up a class, and I've put in the main method in here. Okay, so we've been seeing this for a while, but here's where the new exception handling, let me put that in there, exception syntax goes. It goes inside of the method, okay? It doesn't sit outside of a method. But it's going to look like a block of code. And a block is anything, a block is really anything between curly braces. So this is the try block, this is a method block, and this is a class block. Let me highlight that better. This is a class block, okay? And basically have blocks inside of blocks inside of blocks, okay? So the try block, this is where code, this is what is called the guarded region. Now what happens in the guarded region? The guarded region, this is where you put the code, place code here, and this is critical, that, and notice how I'm highlighting it and capping this, may throw an exception. Okay, this is where you put the code that may throw an exception. You're hoping that it doesn't throw an exception. Okay, this is the code. This is what you put there. Now, when the exception is thrown, you will have a catch block. Let me just say now, the catch is optional. And later on, I'll talk about bubbling up or calling up through the call stack. But you put the catch here. Now, every type of method that you call throws a particular exception. And the exception is some kind of an object. Okay, so you might put in here like my exception 1. Then the code that goes here, this is the code that handles the exception. Okay, this is the code that handles the exception. So what's going on is the main method is called, and it goes into the try block, and it starts executing lines. Let's say there's several lines here, okay? Let's say line 10 does something, line 11, line 12, line 13, and line 14. They do something. Let's say it creates an instance of an object that allows you to open up a socket. On line 11, it calls the method to actually establish the connection to some server across the network. The server's down for whatever reason. It's inaccessible. Boom. The exception is thrown. Then what happens is the exception of a specific type is thrown. And I'm going to show you how you know what type of exception to throw. In this case, it could be like socket error. The socket error is thrown, then it starts looking for a catch block that will deal with that socket error. Once that catch block happens, then program execution shifts to the catch block. Now, you can catch many things. You can have several. And the order that you put these in does matter, and I'll talk about that more in a second. So you can have catch exception 2, and here's a block, catch exception, I'm getting lazy. How about my XCP 3? And here's a block, okay? So what happens is, in the try block, a certain exception will be thrown, and then it starts looking. Is this it? Nope. Is this it? No. Is this it? No. Now, if none of them happen, it will go up to the method that called it. Okay, now, the main method is the kicker here. It starts everything off. It kicks off program execution. So if an exception occurs in the main method and nothing catches it, it can't go up to someone else who called it. So what happens is it passes it to the Java virtual machine, and then you get a serious error here that is pretty much unrecoverable. So what you want to do is you want to use exception handling throughout your classes such that hopefully the exception that you put at the main method it will eventually catch. Now, you can tell what type of exceptions you're going to use, and we're going to be looking at a lot of those here in a little while, all through the rest of the course, because Java, depending on certain methods that you can't even compile. It forces you to do exception handling, which is something I like. I think it's a good thing to do. Now, there's something that I need you to think about here, and let me put some pseudocode in here. Pseudocode is just basically bogus English code that's not really Java. Let's say line 10 says create a database connection object. Okay, so we're going to create an object that allows us to open up a connection to the database. Line 2 says, or line 12, I guess, says open the connection to the database. 13 says create an object to query the database. 14 says execute the query. And 15 says display the results. And then 16 says close the connection. All right. Let's think this through here. Let me get rid of this one. I want you to be able to see the whole, what it looks like completely here. So let me just kind of scoot this up so you could kind of see here. Let me just get rid of this one line here. Okay, so that's fairly good. Here's the class. Here's the main method. This whole block is the main method. Within the main method, this is where our try catch goes. Now, remember earlier I said that when you have the try block and you're executing lines, you basically execute those lines sequentially. So first do this line, then 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 do this line. Well, the try catch block works like that. And what happens is, let's say this line executes, then this line executes, line 11, where we open up the connection to the database. If the database server is not accessible for whatever reasons, the network is down, there's a router somewhere on the network is down, your hub is down, your switch is down, the database server itself is down. I mean, I could go on and on as to why I can't connect to a database server across the network. But for whatever reason, it's going to happen. Program execution then immediately leaves the try block, the exception is thrown up into the air, and then these catch that ball's gonna come down, that exception object, if you will, and it's gonna start looking for the appropriate exception. So let's say we have a database connection exception. I'm going to use XEP as an abbreviation for exception, and we have a query exception. Okay, so the database is not available. Boom, immediately we leave the try block and we start looking for the appropriate exception. And here, since we're having a database connection issue, this code will fire off. And maybe it is simply code to go ahead and choose another database server. Or maybe you've got the wrong name of the database, so choose another database. Or there's a ton of reasons why you can't connect to it. Maybe you need to supply different logon credentials. Okay? Now what you have to understand is I'm gone. So now that I'm in this catch block, am I able to go ahead and create my query object and execute the query, display the query, and close the connection? No, I'm not. Now, I could write some code that says basically rerun main, fine, and I can do that. What I want you to focus in on here specifically is the close the connection. You see, that connection will never close. And you should always close connections to a database. You should always close streams to files and network cards. Basically, I don't want you to sit and focus on database programming right now because we're going to do that later. But cleaning up, this is called cleanup code. And cleanup code means that if you open up a resource, like a connection to a database, a stream to a network card, a stream to a file, okay? If you open up some kind of a resource, you need to close that by literally calling the appropriate close method to release that resource. Otherwise, you're going to bog down that computer and potentially take up a lot of memory. So what happens is there's an optional block that I could put at the end of my try catch block is called the finally block. And the finally block is a place, and it's optional, but I can do it here. And this is a place that always runs, no matter what. So if I leave my try block, go into a catch block, then after the catch block happens, boom, I always run. And this is where you want to put your cleanup code. So place cleanup code in here. Do not put cleanup code here. The try block always, the finally block always runs, no matter what. Now, I say no matter what, and that's just not true because, listen, if you have some kind of a fatal system error that causes your computer to lock or crash or you lose power to the computer, it's not going to run. But let me tell you this. For 99.99999% of the time, it will run unless you have some, act of God, so to say, or catastrophe, so to say, that, literally won't prevent that to run. They're not required, but it's a good place to go ahead and put your cleanup code. Earlier, I talked about the fact that the Java API is going to force you to handle exceptions. You're going to have to deal with it. So let's take a look at some exceptions and how you're going to learn about them. Let's go to, first of all, java.lang. If you recall, java.lang is a package, and this is where the core functionality of Java can be found in this package. Now, all the packages are broken up into 3 sections. The packages will contain interfaces, we talked about that, classes, and then if we scroll down to the bottom, we will have exceptions. There's an arithmetic exception, an array out of bounds exception, just the exception class. I'll talk to you a little bit more about that here in a bit. So you can see that the different exceptions are implemented as a class, and you have to know which exception to use when going ahead and using a certain method. Well, how are you going to know that? Well, let me show you. Java has a namespace entirely for utilizing databases called java.sql. And if we come into java.sql, let me click that, we'll see that we've got some classes in there that can help us. For example, we have a connection class. So let me go ahead and take a look at that. It's actually an interface. Load that connection, and this allows us to specify a database server and every type of information about a database, and it will establish a connection. Now again, I'm not teaching you how to work with databases just yet. We're going to get there, okay? But right now I'm just giving you an example that I think is a little bit more tangible that we can understand. Let's scroll ahead and take a look at some of the methods in here. One of the methods is the close method. So let me kind of find that here. And what does it do? It releases the connection objects, database, and JDBC resources immediately instead of waiting for them to automatically be released or timed out. But again, what if something happens to where you can't close that database session? Let's click on the close method. Look at this. This is the method declaration. Public void close, look at throws SQL exception. It throws the SQL exception class or SQL exception object. That means that we have to deal with this exception in our code. And if we don't, we're not going to even compile. Let's scroll down to the bottom here where we see the various exceptions. And here we see SQL exception. Go ahead and click on that, and we can see that we have the SQL exception class. The SQL exception class inherits from the exception class, inherits from throwable, inherits from the object class. Let's take a look at how it's defined. Public class SQL exception extends exception. And we could see that here. And here we could see what's going on here. And if we go in here, we could see that the SQL exception class has some things. And it's a normal class. We have constructors. We have methods of that class, okay, that we can do things. And here we could start seeing its family tree. So all over the place, the Java API is going to force us to implement exception handling in our code. And I think that's a great feature of Java, by the way, that it forces us to handle exceptions. So let's go ahead and put one into practice. To demonstrate working with exceptions, we're going to play around with arrays. And we've talked a little bit about arrays before, and we see that we have an array that's automatically built for us utilizing the main method string array. So let me kind of get rid of this, because first thing we're going to do is just go ahead and bomb it out on purpose. So let's clear this up. And I'm going to go in here and I'm going to do system.out.println, and we will print args position 4. We will go ahead and print out args position 4. Let me close that. Close it up. All right, so let's go ahead and compile. All right, so that compiles. Now I'm going to hop out to a command prompt, and I'm going to go into my CMD, bring up a command window, and let me change into the appropriate cd java/exceptions. All right, and I'm going to do a Java. Just let's dir it so I can see what we have. Dir star.java. There's my Java file, dir star.class. There's the class. So Java exception 1, and I'm going to put hello. Now, if you recall, hello is the first position in the array, which is array position 0, index position 0. But what am I doing? I'm asking it to print out 4. So if I go ahead and run it, let's see what happens here. It's trying, it's thinking, and I get an exception. I get exception in thread main, java.lang.array index out of bounds exception. Okay, it throws that. Now, here, I, as the end user, am witnessing that horrific error, but I don't want to do that. And just to prove to you that it'll work if I put in 4, let's do a Java exception 1, and I'll put a couple of strings after it. 1, 2, 3, 4. And I typed 4 after it, so, Java 0, 1, 2, 3. Look at that. Remember, it's 0 based, folks. Even I sometimes forget that. All right, so here we go. 0, 1, 2, 3, 4, 5. And you could see it's printing out 5. No problem. So it does work. But if I mess it up, I get an error. So let's be kind, and let's go ahead and utilize a try catch block that instead of presents that horrible error, it presents a nice message to the user. So I'm going to surround the code inside of a try block. Remember, the try block contains the code that may throw the exception. And I'm going to go ahead and catch, and here the Java error tells me it's the array index out of bounds exception. Yes, that is a very lengthy name. However, that's how they do it. And eventually, you'll get fairly used to it. So I'm going to cheat, I guess, and I'm going to do an old copy paste trick. So I'm going to take mark and highlight. Let's highlight all that and hit enter to copy it. And I'm going to put it, oops, not there, but here. And it's going to be array index out of bounds exception, and it's going to come in as XCP. And what I'm going to do is give myself a nice little catch block, and I'll do a system.out.println, and I'll just say something like, oh, an error has occurred. Please try again. All right, let's compile that. Very good. Let's go back in here and run it. Here, I'm going to run the mistake one. So let me hit enter and watch what we're going to get instead of the error. And so, look, it says an error has occurred. Please try again. Okay, in other words, what's happening is I've coded a nice little message to appear, and it comes. Notice above it, we get the exception handling and all that kind of good stuff, okay? Or rather, above it, that's what happens when we don't have exception handling. Below it, we get our nice error message. So that is how to go ahead and implement exception handling. I like the way Java organized their exception classes. We've talked about inheritance, and Java is just one huge inheritance structure. Everything coming to java.lang.object. And exceptions are no exception. You see, java.lang.object, I said it's like Adam, okay? It's the root. It's the first class. Everything extends from it. Now, exceptions have a nice little inheritance tree. You can see exception class is itself is a type of a class, and all exceptions inherit or are derived from simply java.lang.exception, which itself derives from throwable. Now, throwable has two children. It's got the error class and it's got the exception class. The error class, this is serious, serious stuff. As a matter of fact, we as Java programmers are not responsible for dealing with errors in our code. Let me go back out to the API here and show you what kind of things we have available to us in the error class. So here I'm in java.lang and I've got my classes. Okay, we're used to seeing that. If I come down, start scrolling down, here are my exceptions. I already showed you like array index out of bound exception, arithmetic. Here's the exception class. Okay, scrolling down here, we'll start seeing, oh, I wanted to show you throwable is a class here. Okay, that all exceptions here from. But look at here. We have a list of errors. The root is error. But we could have, for example, like an abstract method error. We can have an internal error, a linkage error. And we are not responsible for dealing with those. As a matter of fact, our code compiles if we don't deal with them. Basically, the Java virtual machine has to handle them. And if we're getting errors, we got some serious issues. So we're mostly going to be dealing with exceptions in our code. And we have the ability to create our own exceptions by extending either runtime exception or exception. In handling exceptions, we took a look at how Java allows us to deal with exceptional conditions, things we can't predict. Mostly we're not dealing with errors in our syntax or our logic. Mostly we're dealing with unexceptional, or rather exceptional things that happen with resources that we're trying to have our programs use. For example, we're trying to connect to a server across the network or look for a file that just isn't there. So we went through some terms, what an exception is, what thrown is, what an exception handler is, and what catching is all about. Then I gave you the syntax, and we took a look at the try, catch, finally block. And then we went over the exception API inside of Java, where I showed you the family history, or the family structure, rather, of exceptions. I hope you have found this informative, and I'd like to thank you for viewing.